Hey guys, so I want to show you a few more inclined plane problems. Let's jump right into it. So here I have a system that is at equilibrium, which means all these forces are canceling. There's no acceleration and no velocity. The masses are 1 kilogram for the 1 and 2 kilograms for the 2. And this angle here is 53 degrees, okay? I want to know what is the tension 1 and tension 2. And notice that the surface is frictionless, no friction. So right away, I hope you can see before we start solving this that T1, T2 has to be greater than T1 because T2 is holding both blocks at an angle, whereas T1 is only holding one of them, okay? And this is at equilibrium, so forces are going to cancel. First thing you should do is draw a free body diagram. So let's draw a free body diagram for the first object here. And what are the forces? mg down. Let's call this m1g. This is normal of the first block, so normal 1. This here down the plane is mg or m1gx, and this here is m1gy. And then I have tension 1 right here. This is the first object. Let's draw the second one. Again, here's the inclined plane if you want. If you draw that, that helps a little bit. And here's block 2. Now, what are the forces on 2? I have m2g, m2gy, m2gx. I have tension 2, pulling it up. And I hope you realize that there's also a tension 1. So if you look at object 2, it's being pulled down by tension 1. Remember, the direction of tension depends on the perspective of the object. So if you're 1, you're being pulled up by T1. And if you're 2, you're being pulled down the plane by T1. Okay, those forces have the same magnitude, just different directions. All right, so now I want to find T1 and T2. Okay, T1 and T2. This is an equilibrium question, or problem, so that means that the forces will cancel. And you should be able to quickly look into this and realize that N1 equals M1GY. And then N2, I forgot to write N2 over here. N2 is going to be the same as this, okay? And also on the x-axis, forces will cancel. T1 will cancel with M1GX, and T2 will cancel with T1 plus M1GX, because there's two forces in the x-axis, right? So I could write as many as 4 equations here, but it's simple equations, just saying this equals this equals this, right? Now, if you try to solve, you always want to start with the simplest object. Simplest object has the least amount of forces on it. And here, this first one is the simplest because it only has 2 forces here. If you start here with the second object, you're going to write that T2, let me write that real quick. You're going to write that T2 equals T1 plus M2GX. And the problem with this is that you don't know T2 and you don't know T1, okay? If you go to the simpler object, object number 1, so I did this kind of out of order, but it's okay. T1 equals M1GX. I don't know T1, but I can find M1GX. Okay, M1GX is M1G. X goes with sine on an inclined plane, so it's M1G sine of theta. Mass is just 1. Gravity, I'm going to round it to 10, and then the sine of 53, which is just 0.8. So if you do this, you get an MGX of 8. If I calculate MGY, well, I don't need MGY. So MGX is just 8, so that's it. MGX is 8, T1 equals 8. And now that I know T1, I can simply plug it back in here, and I'll be able to find T2. T2 is T1, which is 8, plus M2GX. M2GX is right here. M2GX is mass 2, which is 2. Gravity, which is, we're going to round it to 10. And then the sine of 53. This is just 16. So it's 8 plus 16. Tension 2 is 24. Okay? So the first tension is 8. The second tension is 24. Like I said, it's tension 2. We should have expected the tension 2 to be greater. In fact, if this is 1 and this is 2, you can see how T1 is holding 1. T2 is sort of holding 3. So it makes sense that T2 is 3 times larger than T1. Okay? Now I have a practice problem here, and I want you guys to give this a shot. I know it looks very scary because you have two inclined planes, the angles are different and whatnot. But remember, ultimately what's happening here is forces are canceling. So you can say force in this direction equals force in that direction, and you might be able to get this. So give this a shot, let's see what you get.